Hi everyone, my name is Farid Zidat. I am PhD Senior Application Engineer within Altair. I am going to talk today about how to determine the stall torque using Flux. So let's use again this Flux project. It's a permanent magnet machine defined with IPCN, so current sources, impulse speed, right, with control angle, and the gamma, control angle gamma. Previously it's not control angle, sorry, but it's initial position. So the current sources are defined like this, three-phase balanced system. Okay, I want to modify this project in order to determine the stall torque and the stall current. So first of all, I have to go to the rotor and impose the speed equal to 0. This is what I want to do. So parameter speed, I will switch it to 0 here. And then I have to modify voltage sources to, from current sources to voltage sources. To delete them all. And I have to impose voltage source like this. And I will rotate them. Okay, once I did that, I have to define voltage sources here. Okay. Maybe I will first delete all the scenarios. Here, this parameter, I will modify it to voltage and defined as via scenario. Okay. Apparently, this parameter is already used, so I have to delete all where I am using this parameter. Okay. Or maybe let's create from scratch other parameters for voltage. So I will call it this voltage parameter created by scenario. So I have use 10 value, 10 as the initial value. I am going to use the same formula as for the current. So I have to create V1 and by formula here just modifying by voltage. Okay. So here I am going to create V2. So just to recover the same formula here. And of course modify voltage. And then I have to make the third one, and here I just have to modify like this. So then once I created my parameter voltages, so I have to assign them here. Here I have to put V1, double click on source 2, V2, double click on source 3, sorry, here, and let's put a V3, okay. Then I have all what I need here. If I check the physics is okay. Yeah, so I told you I am going to impose the speed at 0 because it's a stall torque. Then once the speed is equal to 0, the frequency is equal to 0, and here all what I have with omega, the electrical pulsation will be equal to 0. So it's like I am imposing a DC voltage on the three phases. Okay. Then when I did that, I have to create a scenario where I drive the RMS value of the voltage. Once again, if I impose a DC voltage, then there is no magnetic flux variation. So the inductive part of the impedance is 0, right? So it's like a pure resistance we have here. Then if we have a pure resistance here, we have to make a voltage supply with a very low voltage supply. So then we have to be careful, and let's define our scenario like this. So this scenario I'm going to define, it's a DC voltage, so I have just to vary the time here. Let's say that I have 20 milliseconds and I want to reach scenario solving to until 60 milliseconds, 3 electrical periods if we have 50 Hertz. But here again it's DC current, DC voltage, sorry. So let's make it like this. And linear value 61. Okay. And we can vary the voltage here, but from 1 volt to 5 volt to start with like this. Apply. I can make a distribution. Okay. I can now save the project, and I can go to solve the project in a new project. Altair, solve. Save. Okay. And let's wait until the solving achieved. Yep. Once the project is solved, then we can plot, for instance, the torque, right? And here, since I varied for several value of the voltage supply, I can plot the torque as a 3D curve. Okay, and I can show it like a multi-curve, a 2D multi-curve. Okay, so here for each voltage supply, 1 volt until 5 volt, we can see the stall torque, and we can as well plot maybe the current as a 3D curve as well, maybe on the current, on the voltage sources. Okay. So we can see the current supply on the voltage sources. Okay. Then we have here, as expected, with a small value of the voltage, we do have a high value of the current. So depending on the voltage you are going to have, you are going to have a given value of the torque as well as a given value of the current. Yeah, so then this is what the test to obtain the stall torque. Please note that for a given value of the torque here, you can as well use your KT characteristics in order to recover the current when there is inductive supply, so when it's not a DC voltage you are going to use. So then if you, for instance, I have here 440 Newton meter, I can go here and look to my KT, 440, yeah, it's here. So I have the current. If I impose a speed and the frequency, RMS value of 8 100 amps. And if I come back to the DC voltage, and when I look to my current, is a little bit more here when I use DC voltage. Okay, so in the other hand, it's a RMS value. So maybe if I divide 900 divided by 2 square, yeah, it's still more or less the same value of the current. Okay, so here we have DC voltage, then we have the current corresponding to the DC voltage and the torque corresponding to the DC voltage. This torque can be used as well to determine the current, the RMS value of the current from the CATI curve you have. That's all for me today. Please feel free to ask questions on the forum or on the support, or maybe let a comment here. Thanks again. Bye.